My name is Richard.
I'm Edgar.
And right here in front of you guys, we have the smart stove. Generally, most household fires start within the kitchen, and this is because you will leave your stove or burner on while you're doing, gardening outside. Or let's say you actually go to the store and you forget to turn off the burner. Something nearby might catch fire, and then from there it all goes pretty much downhill. Edgar will demonstrate how this project works.
So the first part and the main important component of our system is a non-contact infrared temperature sensor that will detect the object temperature of what is directly in front of it. In this case right now, it is a pot of boiling water, and if a stove was left on, then it would detect the temperature of the heating coil that is heating the water up. From there, the sensor is connected to a prototype board that has all the resistors and capacitors allowing the temperature to be read and feed into our program, which also is controlled by an Arduino Uno microcontroller and powered by a 12-volt battery. The purpose of our system is that if the sensor reads the temperature as too hot, which would be the temperature of the coil directly, then an electromechanical relay will be activated, which will cut off the power from the wall outlet and also turn on a buzzer, which will sound an alarm, alerting anybody that they left the stove on. Right now, the sensor is recording the boiling water temperature. It is currently being tracked in real time and is displayed on the serial monitor of our Arduino code.
Alright, so as you remove the pot, our sensor will detect that the ambient temperature that it's detecting will start to rise. And when this does occur, once it hits a threshold, our buzzer will turn on. And after that, our electromagnetic relay will switch states. And this will cause the burner to shut off completely. At the same time, once the temperature starts to decrease, the buzzer will also switch tones. And this is to alert you that in case that any of our components back here malfunctions, you still need to come back and turn your burner off. That way it doesn't start back on. Here's our demonstration of how the system actually works. And then after that, this second tone, it will remain on until you actually come over and reset the whole system.
What I learned in this project is from the lectures in class about transistors. Here were our transistors being used to interface with a larger source of power, which in our case would be 12 volts of battery, when our Arduino can only provide 5 volts. I also learned how to size the transistor to be using certain resistances to be able to run from 5 volts of power.
So for this project, I actually learned how to use a relay, which in this case is rated at 120 volts. Originally, we bought a relay rated at 240, but we confused the operated current used to turn off the relay with the actual rated current that comes in from the wall supply. My contributions to the project was buying the burner. I also built the wooden structure downstairs at the ME shop. And I also interfaced the relay in order to handle wall voltage and be able to power up the burner.
My part in this project was sizing the transistor, connecting all of our circuitry, soldering all our points on the circuit board, as well as writing some of the code that works with our program to run with the sensor.